Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Aviation Week webinar. Advanced Additive Manufacturing. This is aerospace's ticket to qualifiable part production, and it's sponsored by Velo 3D. I am at Hazelwood. I'll be moderating today's event. We have just a few announcements before we begin. So number one, this webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, and participate in the Q&A session that takes place during a presentation. The slides will advance automatically throughout the event, and you may also download a copy of the slides via the resources widget. Towards the end of our webinar, we are going to ask you to complete our survey. It's found on the right-hand side of your screen. So please take a minute to fill this out before you leave us today. Your feedback helps provide us with valuable information on how we can improve future events. And lastly, if you are experiencing any technical problems, please click on the Help widget found at the bottom of your screen. Or you can type your issue into the Q&A area, and we will be glad to offer you one-on-one assistance. So now on to the presentation. Advanced Additive Manufacturing, aerospace's ticket to qualifiable part production. So discussing the topic today are Glenn Case. He's the founder and CTO of Hermes Corporation. Rob Sladen, co-founder, chairman, and CEO of Zulu Pods, and Matt Karish, the technical business development account manager at Velo 3D. So to learn more about our prestigious panel of speakers, be sure to check out their impressive bios in the Speaker Bios widget found within the webinar platform. So, gentlemen, we're going to go on and begin. And so, for starters, I'd like to toss a couple of questions out to all of you to jump in and answer. And it's a pretty broad one here to start with. How do you see 3D printing evolving within aviation and aerospace markets over the next few years? Who wants to go first?
I could jump in to start. Thanks, Ed.
Okay.
I look at this as I kind of look at this as five different things that Zulu Pods and I see happening. We'll continue to see material property development, and that'll turn into trust. We will also continue to see more use of 3D printing in major defense development programs. 3D printing will certainly provide supply chain relief, especially when we think about the casting world. And then once we get that trust, once we see more of this in major development programs, you'll start to see the conversation transition where the normal conversation will be forgings, castings, 3D printing, right? When you start to think about raw material selection, when companies are designing new products. And then we will ultimately see improved performance, right? When we look at what 3D printing allows for, it allows for unique geometries that are not available today, and that'll allow for improved performance in really complicated systems.
Glenn, what do you see in the future?
Yeah, I think for us, it's not necessarily a material properties thing in terms of yield ultimate, those types of properties. It's really a fatigue issue for us. So I think advancements in, the powder bed fusion side of things that allow us to make parts that can fly on airframes that last 10 plus years, right? I think 3D printing has found a great home in, systems that fly dozens of times. Certainly we're going to be using some of those systems and developing some of those systems that are of that nature. But to get wide adoption into the general aerospace, if you find it on a 737 or something like that, those types of fatigue properties are really what is going to be the proof of the pudding in the future.
Matt, how about you? What do you see for the future?
Sure. So I think it's no different than any other manufacturing technology out there, right? And if you look at how parts are made today on, like Glenn mentioned, things that are going on 737s, right? They're using well-known technology that is well understood and documented and proven. And that exists because that technology is mature and repeatable and reliable, and people know what to expect, right? So for additive manufacturing to kind of be on par with those other technologies, it by default must start to become repeatable, reliable, dependable, and have people be able to predict and design to what will come out of these systems, not just a one-off unit, but a full supply chain worth of these technologies. And so in my view, it's all coming down to additive finally living up to the promise of what it was supposed to be, of this kind of easy manufacturing technology that allows you to do all these complex things and come up with these new geometries and improve performance and function and reduce costs and all that stuff. But in a production environment where material properties are repeatable and reliable, and the systems are giving you the same result over and over. So yeah, in my mind, it's really just focusing on true production technology here.
Okay, so Matt, that kind of leads right into what I wanted to hit with the next question. And so maybe we'll reverse order you guys this time around. And that's the issue of trust, because establishing trust in metal AM can be difficult sometimes. So how do you build trust, and what specifically gives you trust in this? Matt?
Yeah, coming from the engineering world, I think something you'll see common in most engineers is taking this like trust but verify approach, right? And so even with existing technologies, you're going to go do qualification parts and first article builds and things like that, right? That's just going to be standard. But to build trust, we're going to have to start creating these databases and having the term that's kicked around is pedigree data, where people can see exactly how that information was generated and go recreate it themselves and prove it to themselves that, yes, on this technology, I can go do the things that they have promised I can do and generate the materials that I'm expecting to generate out of the machines.
Yeah, I think also like when we really talk about trust, right? Trust is built on relationships, and creating those relationships not only between the individual engineer and the additive OEM, but also those relationships between the airworthiness authorities, the FAA, the Air Force airworthiness, those types of relationships between the OEM, and building those types of relationships, because really additive is still looked at today as, at least in my view, that it's still got a ways to go before it can make it on major programs, and I don't think that's the case at all. But I think that's those barriers you can break down those barriers through relationship building and just talking.
Yeah, I would just add, kind of tack on to what Matt's saying. I mean, I look at it as it's got to be looked at as on a part by part basis. We need to be able to build statistical confidence in acceptable variation when we print part after part, no matter where we're printing it in the world, no matter what machine we're printing it on, and then we need to also build statistical confidence in the validation testing, right? In the parts real life system parameters. And so I kind of look at it as those two things. And once you start to do that, I think it makes it easier to have those maybe perceived tough conversations like Glenn's getting at that don't need to be that tough, because I think we're further along than what some of these bodies would give us credit for in this world.
Hey guys, I know you have a couple of slides here that you want to talk to, so why don't we jump to the next slide that's in the presentation here, and let you guys talk to that.
All right.
There we go.
So Zulu Pods reimagines lubrication system design for the modern world. We are based in Florida. The company was founded shortly after a car ride to Orlando. My wife and I finally had some quiet time with our kids sleeping in the back seat. We're both aerospace engineers. We started talking about this idea of a Tide Pod for the jet engine with one-time use engines in mind. We started talking about, imagine if we could package just the right amount of oil for a given mission and start it very close to where it needs to end up, reducing the amount of distance it essentially has to travel. This would eliminate parts, simplify the supply chain, lower the carbon footprint, and improve overall engine performance. On the left, you see a traditional, what we would call a connected system, just like the one you have in your car, and that exists on many jet engines. But if we think about your car is designed to last hundreds of thousands of miles, right? If you asked Zulu Pods to design your car to last a mile, we'd design it differently. Again, think about one-time use engines. Keep that in mind, 1 hour type of missions. So on the right-hand side, you see our Z-Pod technology. You can see that the thing on the left is quite complicated and would not be able to be held in my wife's hand. So we miniaturize complicated mechanical systems into something that can truly fit in the palm of your hand. We package just the right amount of oil for the intended mission. In this particular example, this is a dynamic solution. So this actually lives inside the center of a jet engine shaft. And then when that one-time use engine turns on, the pod is activated, and then we have very complicated, well, not complicated, it's pretty simple, metering technology that allows us to deliver oil over the course of the mission. And, that's a little bit about who we are. I guess in the spirit of our technology being very simple, I'll keep this intro pretty simple as well.
All right, next slide.
All right. I think actually we're going to break for me. I've actually got to share my screen for you guys.
Okay.
Let me do that really quickly. So for those that aren't familiar with Hermeus, big picture, long-term goal is to radically accelerate the global human transportation network. Think, New York to London in about 90 minutes. However, we'd be a bit naive to think that we could go and do that and go out and build a transport class aircraft, and raise $6 to $10 billion and, with venture capital money or private equity. It's a pretty tall glass of water there. So we have to de-risk the business case through, an iterative roadmap. And we're starting with that with Quarter Horse, which is designed for high Mach flight testing, basically get up to high speed and be reusable. Follow-on products include Dark Horse, which has about 2,000 nautical mile of range, 2,000 pounds of payload, and it can do things that are pretty interesting to $3 agencies out there. And all the while, that kind of de-risks a lot of the technology associated with building Halcyon, which is what our Vision aircraft is for that transport, which is about a 20-person cabin and that can fly transatlantic. A little bit about our additive endeavors here at Hermeus. We made a significant investment in additive here. One of the reasons is simply, eliminates a lot of the costly and long lead tooling requirements, right? If you're talking about castings that could be, 12 to 24 months, especially in this particular environment, it's a very long lead item at the time to get those, or forgings or anything like that. So this allows us to sort of circumvent that at basically the cost of price, right? But it also improves our fly to buy ratio of really high value alloys. When you're flying at Mach 5, the gross acreage temperature is around 700 degrees or so. It puts you squarely in the titanium world, and the flow path of the engine, it puts you in the nickel-based alloy world. So those alloys aren't cheap. You really want a high fly-to-buy ratio, and that's something that additive allows you to do. So not only have we invested with Velo in their powder bed fusion technologies in both their Sapphire and Sapphire XC, but we're also investing in large format additive on wire laser technology there that we envision in the future that we can, print entire wing structures potentially, as space isn't really the limit there. A lot of challenges with dealing with that, but you're able to lay down a lot of material quickly, but also line that up with a subtractive process as well on the back end. Wanted to share a few pictures here and how we use additive. A lot of the ram burner that we have, our Chimera, our engine that's powering that first vehicle, is 3D printed. Most of it has, printed in sections. I think the Sapphire XC will allow us to kind of print on a much larger format. And then beyond that, picture on the right here is a fully integrated engine, and that bypass duct on the right there is completely printed with that large format printer. We're also doing a lot of things with the vehicle, incorporating a lot of additive inside the vehicle. I don't think much is shown here on the pictures, but certainly they're finding their way into major aircraft structural assemblies and the like. But yeah, that's me in a nutshell.
Wow, that's impressive. So quick question for you, Glenn. Do you utilize contract manufacturers, and can you speak to how you have found that experience to be?
Yeah, we do. We use, from our seed round till, up until now we have the Velo. We definitely use contract manufacturers. We don't have enough capacity to really satisfy everything that we want to do. The reason we bought one, though, both the Sapphire and the Sapphire XC, was the fact that, I've been dealing a little bit with additive, probably going 10 plus years now. With Blue Origin before. We invested in it pretty early. Back then, you could get parts in a couple of weeks. You really could. There was enough machines out there that could satisfy the market. And the market's expanded so much, the demand has expanded so much, and there's just not enough machines out there, really. And, for something that's relatively simple to print, you're waiting months sometimes to do that. So one of the things that really attracted me to the Velo machine, though, was that the consistency from machine to machine and the ability to create print process parameters for our Velo machine and being able to send that out to our other contract manufacturers that can essentially, double up our capacity whenever we need it.
Okay, Rob, I noticed you sort of shaking your head yes to a lot of what Glenn was saying. Any comments on that?
No, we are in a similar position, in terms of, I guess I'm kind of shaking my head just when Glenn started talking about their financing rounds and, not being able to go buy a printer in a seed round, or for us, we're raising our seed round right now. So we leverage their technology and their CM network quite a bit. The goal long term is that we will be able to bring some of that in-house as we raise more capital.
All right, should we jump to our first poll question? Let's, how do we get that up there? There's our first poll question. You get it up there by saying, how do you get it there? And poof, it magically happens. So, ladies and gentlemen, for the audience, here's poll question number 1 for today. What best describes the reason that you are joining today's session? So we're exploring bringing additive manufacturing technology in-house. We're looking for additional information on Velo 3D's end-to-end additive manufacturing solution. We want help with a specific part or application or some other reason. So if you can click and answer this for us, I'm going to give you a little Jeopardy music. So here it goes. Dun, 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 da, 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 dun, 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 da, da, rum, ba-dum, bum, 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 bum. And I'm going to give you a little bit more time. People are answering. I can see it coming in there. So this will give us a sense of why you're here, and then that will let our presenters talk perhaps a little bit more specifically to what some of your needs might be. So give it just maybe get 5 more people to come in. Come on, you can do it. And okay, maybe we should go to the results. And here we are. Here's the results. So we've got 23% are looking to bring it in-house. Some are looking specifically for the Velo 3D solution. Very few down there on specific parts. And other, I don't know what that other is, but most people went for other. But so, gentlemen, there you go. Anybody care to comment on that, or is that about what you expected?
Seems reasonable to me.
Okay. All right. Yeah, Matt, you're the one I thought. I mean, you're with Velo 3D. I figured you ought to comment on that. Okay, great. What sort? This is an all question again. What sort of repeatability is achievable with advanced metal AM? I'm assuming that's going to be pretty high, but for the audience, let's get that out there.
Yeah, so I think it all depends on how you define repeatability. And is it dimensional? Is it a flow check? Material properties? All the above, right? We like to think at Velo that we are highly repeatable. And again, it comes down to a lot of the things we've designed into the system. The most recent, I'll say, use case or case study, if you will, that I can discuss is at a high level without naming companies or anything. We had a customer utilizing what we call our golden build file, where Velo helped develop the build file and the print file and used essentially that one source of truth file and sent it out to our network of printers to produce the exact same part. And then they brought those parts back in-house and did a flow check on them where they got this flow coefficient. And they had an existing supply chain for these components on, we'll say, legacy manufacturing systems, additive manufacturing systems. And they were struggling with precisely what we're talking repeatability. And it's features on these parts that are very critical to the performance of these components. And so when they went and more or less tested this concept that Velo has of a golden print file, they saw within a single machine variation of on the order of 1 to 2% within a single component. And then machine to machine, the exact same level of variation. And so that's not just a bunch of machines in a single shop, that's across multiple different shops as well. And when they compared that to their existing supply chain was giving them on a single machine similar orders of magnitude variation. But when they were looking across vendors and across machines, they were seeing variation on the order of 15 to 20%. So I think that alone speaks volumes to what our technology can do and the way we've designed this system to, again, be scalable and a true production ready technology without us just kind of, talking the talk. We have starting to collect data that's proving out all these things that we're trying to spread the gospel about, if you will.
Yeah, I'll second that. We had a couple of components that we printed on another platform outside of Velo, and we had a couple of components that were basically mirror images of each other that needed to fit up pretty closely. And the one company had some time, found another supplier that had some time, printed them side by side. You would think that would be pretty spot on and close, but there was a significant gap, of misalignment in the fit up of those. And that's one of the things that are really critical for us is how do we, and I mentioned this before, but how do we, leverage our contractor network out there with a platform that can give us consistent and repeatable results. And that's one of the most critical things for us because one, we're going to spend a lot of time, money, and effort on developing those process, right? That one true file, if you would, and being able to disseminate that to other contractors to kind of beef up our production numbers is important.
Rob, anything or?
I would just, I would say that we're using Velo 3D's CM network and their technology for a reason, right? Because of that one build file, we believe that they are, I'll say, ahead of the competition, or in a place where we think that we can get repeatable, parts. Thinking about the production world, I'd also say, I think Matt brings up a good point in terms of what is repeatable. I mean, it all depends. I go back to, it's a part by part basis, right? There are there could be variation that's plus or minus 5 or 6% on a given surface or a diameter, and that may be perfectly acceptable, right? Because that's not a critical component of the part, or it's not a mating diameter, or it's a profile tolerance that nobody really cares that much about. So I always go back to it's a part thing, right? You got to look at every part distinctly when we start talking about this repeatability thing.
So we have a lot of audience questions. A lot of audience questions have been coming in. So the first one I wanted to ask was, are there industry standards out there that define the steps needed to certify additive manufactured parts for aircraft, essentially FAA, EASA type of certification standards?
Now, that's probably a good question for you.
I was going to ask what you guys are using, Glenn, since you're actually making an aircraft. I'll answer that. We don't actually, we've developed most of our parameters in-house, right? We have our own in-house stencil testing. We come up with, and this is the point of the question, right? When do you not have to do that anymore? That's the whole point, because it's expensive. And, we bought some tensile touch machines, and with clamps around it that can heat up the part and get the elevated temperature samples too. That's an expense that you go through to develop those allowables. And there's a lot of tensile test samples that you have to go pull to create your A basis allowables there. And so how do we avoid having to do that in the future for various things and alloys that we might have to print? I would love to see an investment, be it by a government agency. I would think that there might be some pretty interesting, synergies there with, NASA and the Air Force of wanting to get these things into flight. But until, somebody wants it, it's not going to happen. But it would certainly help us not to have to make all those, especially for the relatively mundane things of TIE 6.4 or, Inconel 718. Just this we generally know what those properties are, but when you take them to the bank, to the FAA and the Air Force airworthiness, they kind of want to know what you're getting and what you're designing too. Yeah, and I think we're starting to see some of the AMS specs coming out for some of the alloys that Glenn's mentioning, right? Like the 718s, the TIE 6.4s, the more popular ones that have been around for a while. And to Glenn's point of having those material allowables, those databases, what Velo is doing or trying to do at this point is start to collect a lot of that material data. And the reason we are able to do that is by creating the parameters within Velo and effectively giving them to everyone who has our technology. Everyone is running the same recipes, if you will, the same laser process parameters. And so by doing that, you have this now sizable, statistically significant fleet of machines that you can go start creating these databases on that have the appropriate variation built into them, like serial number of machines, locations that these machines are run at, powder lots that are put into these machines, et cetera, right? And by keeping the baseline parameters the same, you don't have a ton of noise in the system where your data is essentially useless. And so we're now at the point where we're going to collect this information, not just your basic room temperature tensils, but high temperature tensils, fatigue data, crack growth, cryo properties, those types of things. And taking it one step further, trying to work with organizations like MNPDS and the FAA to get these databases and material allowables into these officially recognized agencies and organizations, so that the smaller companies out there that can't afford to drop $1, $2, $3 million on material test programs can go pick up this data and combine it with the Velo technology, knowing that you're going to have the same recipes available, and go produce that material and get the same results coming back out.
Okay.
I guess I'll take the question just in a bit of a different direction, particularly because Zulupods is we care about short duration missions. We care about expendable engines. So the concept of proving something out that lasts for an hour is very different than proving something out that's going to meet 25,000 hours between overhaul, right? We don't necessarily care about endurance and fatigue as much as people like Glenn and some of Matt's customers do. And so, it's a great place where what we're seeing with our customers and with the Air Force is that they're very open to additive and expendable applications, right? Because you can imagine it's pretty easy to take apart and validate that part, right? I can actually run lots of test cases and get to a point where I could show that something could last 5x the mission, 6x, 7x, 10x, right? And so, that's we think here at Zulupods that could very much build a foundation within the Air Force to then start to get that acceptance. And then we can transition to some of the things that Glenn and Matt are talking about and have, build that foundation there for more widely accepted, parameter gathering, and then being able to share that and have smaller companies be able to have access to that.
Agreed.
So, Matt, we're getting a lot of very specific questions aimed right at you. So I'm going to toss one to you now. Porosity is a major issue in really intricate parts. So has Velo done anything to enhance that?
Absolutely. No, that's a great question, and it's one of the big ones that comes up in additive. And so what we've done, and I mentioned earlier, we develop all of our process parameters in-house. And so we have a phenomenal team that does that work. And we, from the outset, strive to have our parameters come out and our material come out of the machine at 99.9+% dense. And it's not just looking at like your best case scenario of directly under the beam where things are nice and your process windows are wide. We look at the kind of, I'll say, fringes of not only the geometric box that we work in, but also on the edge of where the process is stable. So we look at, for example, very low angle coupons that are growing away from the laser. So it's going to be your worst combination of direction, angle, and distance from the laser. And then that's where we evaluate the porosity within the part. And so if you can hit acceptable level of porosity, again, for us, 99.9+% dense, at this extreme case of challenging geometry and angles and locations relative to laser beam, then effectively the rest of your process parameters are going to be equivalent or better than that.
All right, here's another very detailed one, and it is how do you resolve grain formation on multiple parts, since printing on different areas causes different heat regions? So it's a very technical one.
No, that's a good question as well. And there's some interesting work out there where people are tailoring material properties by controlling things like cooling rate of the metal in the machines. And so it's going to be very alloy specific, like things like 718 that are very friendly to heat treat. You can do a lot of things after printing to, I'll say, erase or reorganize the structure of the material to get different properties versus materials more like a Tie 6-4 that is more dependent on the formation of the solvent itself, where you're going to preferentially grow grains in the Z direction of the build, and it's a little bit more difficult to kind of equiax those properties properties out in post-processing, the process parameters become way more important. And so looking at like the power input and the hatching strategies that you're using become important, and certainly that is something we take into consideration when we develop our parameters.
Okay, so a little bit broader question from the audience, but failure of a component happens. It's a matter of when, not if, and that's true of components that are manufactured also using, traditional established processes. So how do you think the additive manufacturing world is going to react when there is in fact a failure? So thoughts on that? How's that going to be handled?
Yeah, I'll jump on that a little bit. At least my background's been mostly in the space business and also in the air breathing business as well. But in the space business, additive's nothing new, right? Failures have happened all the time. We learn a lot through tests, and those things fail, and it's just a bump in the road, right? It's not something that we're going to throw away the manufacturing technology because I need to add a little bit more here or relieve something there because it's too. The particular design didn't work so well with it. Are there issues associated with getting to a production quality part? Absolutely, right? It's hard you need to print something several times before you get a quality part that you really want to put in the air. But I honestly think, maybe regulators will be a different, than myself. But my vision of the world sees additive as another extension of any other manufacturing technology, and it'll just be a little bump in the road.
Matt, Rob, any comment on that one?
I think the appropriate way for anybody to react is similar to how Glenn's looking at it in terms of and even how the question was framed, right? It's a natural. There are naturally going to be failures that happen, and then people, will dive in and do a root cause investigation, and in some cases it may have nothing to do with the actual, additive, let's say, material properties or even how it's designed. It could be a mating component. I think the additive, if we kind of split, if we look at the additive world in terms of the people like the Velos and the SLMs or the EOSs, I don't think they're going to flinch at all. On the other side, you may get some people that, let's call them the old guard, that get a little more apprehensive. But again, I think we're moving to a place where additive is becoming more accepted today than it was, 3 to 4 years ago, and that's going to continue to happen. And I think that old guard is very much going to look at additive as it's just another, tool in the toolbox that engineers have at places like Pratt & Whitney or Rolls-Royce or any of the large, aerospace and defense companies.
Yeah, I'll add one more thing there. It's that it's the natural evolution of things, yeah. Right? You have. Let's just talk about for a second that it was a material process or a print process problem outside of just a design problem that you had, right? If it was something that slipped through the cracks, well, one, you probably should have been pulling some tensile tests and in process, inspection. You probably should have been proofing your component in flight. But if it did miss all those things, and it truly was something that should have been caught at, the OEM level or something like that. It's that evolutionary step, because I highly doubt that Velo or any other major manufacturers would just turn a blind eye and say, sorry, you get what you get and you don't throw a fit. And no, they'd be interested in keeping in the good graces of the folks that are buying their machines, right? So it's an evolution that improves the quality. And we've seen this time and time out in the history of aerospace of just, systems and material systems, mechanical systems, everything getting better over time and safer over time because of the failures in the past that have created those opportunities to learn.
Yeah, I think if I look back on my previous life experience working on high pressure turbine blades and going through failure investigations from field failures, the first thing that anyone does is immediately go look at all the manufacturing documentation. Right. Mm-hmm. And so I think that is going to be a shocking wake up for the industry. and a real gut check of what is being documented, how is it being documented, what are the controls in place to make sure things aren't changing. And at Velo, we're doing a lot of things today that's already focused on supporting that level of documentation and control. So like these Assure build reports where we're monitoring the process and we're spitting out all the results of every single build and documenting what were the software revisions, what were the names of the builds, when was it run, all this stuff, already creating this kind of quality management system, if you will, within the printing process itself that should tie right into any other existing aviation supply chain. I think in general, you're going to see a strong push towards much more rigorous documentation, if you will, when those first one or two failures happen.
Yeah.
Okay. Rob, let me throw something specifically to you. So I know you're working on turbojet engines, so can you talk about how you're utilizing the 3D printing and specifically Velo 3D on that? And then I got another follow-up question for you.
Okay. Yeah, we love Velo 3D's customer and indirect customer culture, I'll call it, where they really, we're not ready right now to buy any type of a printer, but they very much treat us just like I think they'd probably treat their customers they're directly selling products to. And so they've got people like Matt and teams within Velo that really help, companies that are leveraging AM to design products. So we love that. We love their technology. To date, we've 3D printed our development pods and some test articles that we use in our validation process. If you look at our technology, it's very different than like what Glenn's printing. Glenn's probably printing things that fill up the entire build plate, even when he's using the Sapphire XC. Our pods are really tiny, right? So we can print 30 plus pods at a time on the Sapphire, and then our number will grow substantially on the Sapphire XC, probably 3 to 4x that. Our pods are designed to be hollow, and then we fill them with oil and gas. So 3D printing just makes a lot of sense when you think about the alternative for us, which could resemble some type of a welded fabrication. Actually, when we, in some of our customers to date, we're printing our pods out of Inco 718. When these pods come out of printing, all we have to do is stress relieve it. So we don't even need to do a heat treat or hipping. We don't even need to get to those type of material properties. So, some of our post-processing is not like what, some other folks would have to do. Again, I'll use Glenn. He's probably got to, hip and heat treat. And then when you look at, so think about us, we're a younger company. And so when you look at the contractor manufacturing network that Velo 3D is building, it's beautiful for product development. Why? Because you can create a near net shaped part and then have someone move the part within the same company or building, to machine it, right? And it could actually all be in the same building. So from a logistics standpoint, we don't have to do as much coordination. There's not as much travel that goes on between, I'll say printing and then machining. And then it's allowed us to move pretty quickly in our development stages. Again, not just the pods, but other parts that are complicated that we can leverage 3D printing to build empirical data around our technology. And then our production process, or what we envision in production, is 3D printing. So when you think about what we're doing is we're building that supply chain right now. We're building that production supply chain right now. And so it puts us in a really good position where we have that already in place, right, as we move into production, and we're on a production, on an engine. And then, as we move forward as a company, again, we already have that in place. So if we decide we don't want to vertically integrate, or we want to punt that down the road, it's perfectly okay because we have that robust supply chain already in place. So that's a little bit about how we're using Velo today and some of the fun we're having with Velo today.
Right. So the follow-up question. Recently, I was listening to a Velo 3D podcast, and there was this great interview with Daniela Sladen, and she was talking about new lubrication systems for expendable, attritable turbojet engines. So can you tell us a little bit about that?
Yeah. We are seeing the Department of Defense put more focus on smaller one-time use vehicles, and they're commonly called expendable engines. We think of, let's just for the audience, think of an expendable engine or application as a drone or a missile that will have a one-time use, right, with its entire mission only being an hour, for example. The jet engines that power these applications are not optimized today like they could be. And this means cost and performance is essentially left on the table. So going back to kind of the opening, we package just the right amount of oil and put our pods very close to where the oil needs to end up, right? So if I reduce the distance that oil has to travel from point A to point B, especially because oil tanks and pumps typically hang out on the outside of the engine, it just makes the entire engine architecture that much simpler. And so this eliminates external hardware, reduces part count, and reduces the cost of the engine, all while actually improving performance because of some of the other physics that we focus on and underpin our technology. But there are other opportunities in the market for this idea of a decentralized oil system. So designing large jet engines, I spent 13 years at Pratt & Whitney before coming and starting Zulu Pods, and my focus was, when I left the company, or just before I left the company, I had a stint developing the next generation 6th-gen fighter engine. It's called the ATP program, and I led the mechanical systems team on that entire development process. And so there's very complicated and tough requirements that we get when we're designing a system like that. One of those is called a negative G maneuver. And this is when the plane has flipped upside down, for example. So in a traditional oil system, the oil is no longer able to be pulled out by the pump because now it's gone to the top of the tank, right? And that's commonly called an oil interruption event. And that's where our technology comes in, and our IP portfolio comes in, where we can actually now offer, this really small pod that can actually activate through some of our smart pod technology and essentially provide oil during a negative G event where normally some mission critical part may not be able to have that. And then kind of in the same vein, this toolbox is also a really nice toolbox for this concept of loss of lubrication. And again, all of this, think about it, it's all short duration mechanical system, lubrication system focus. That's what we focus on as a company. So there are times when a single engine fighter or a helicopter may experience an event where the oil system just stops working. And in this case, our technology provides a weight-effective, cost-effective solution that saves people's lives and multi-million-dollar assets. So think about our pods, like the one that Daniela was holding, as this little WD-40 can. And I'll just use this example where MOP, main oil pressure, goes to 0. Now my pod can start to activate and deliver oil and provide mission-critical parts a longer lifetime after a loss of lubrication event. And our technology is truly superior to what exists out there today.
That sounds great. So why don't we go to the next poll question? We have another poll question for the audience, so we're going to get that one up here. And it is up here like magic, just like that. So what are your plans, this is for the audience, to implement metal additive manufacturing within your organization? And this is kind of timeline based. So A, we're currently using metal AM, or we plan on doing this within the next 6 months, or within 6 to 12 months, or a year or later. So if you would click on that and give us a sense of where you are in this process, that would be really good. Once again, here we go with a little bit of that Jeopardy music to get you through this process. So dun, 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 dun. Dun 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 da 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 dun 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 done, dun, 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 dun. I don't have quite as many of you having done this. Maybe I didn't sing quite as well on that one, but you're getting there. You can get a couple of more, and then we'll go to the results and see what it looks like. All right, and we have the results. This looks like most of the audience is currently using Metal AM, over half, 56.5%. We got a few, very few, 4.3% within the next 6 months. A little bit more than that, planning it within the next 6 months to a year, and quite a few still hanging out saying, it's going to take a while. So any comments, Glenn, Robert, Matt, at all? You don't have to. Okay, so I'm going to toss another question then. This is an audience question to the whole group. And so what are you guys doing to develop workmanship standards in support of acceptance criteria? Who wants to jump in?
That's a good question. So clearly, when you, at least in terms of powder bed fusion, and I might talk a little bit more broadly and additive in general, since we do laser wire additive, large format. But one, a lot of the process is developed once you have the process, the print parameters, if you would, and the G code, if you would, to print it. I think that's a pretty self-explanatory thing. After that is where I think the workmanship comes in terms of making sure that what we mentioned before, that you're following the procedures that the company's laid out in terms of documentation, tensile test specimens. The last thing I want to see is somebody coming to me wanting a waiver to get something on a flight vehicle because they forgot to pull, tensile test, or forgot to print in tensile test specimens with that because it was just a lazy thing or something like that. Somebody missed a process standpoint there. I think actually additive probably has the least amount of, it takes a lot up front to get things right, but once you're right, it takes the least amount of touch labor to get you to the point, right? And that's where I really, really love additive, is the reduction of touch labor in what we have to do, right? I have great plans to create entire wing structures out of large format additive, part consolidation with that, but then also getting rid of a lot of the things that are just time consuming on aircraft in terms of, a lot of hole drilling, match drilling with pulling rivets. Any kind of time that you can reduce touch labor is a good thing. So I think that's, kind of got off path there, but in terms of workmanship, it's all about getting the part right, and then in production, it's basically, did you follow the documentation?
Matt, Rob?
I concur.
I don't have anything else to add.
It brings up a good point of the main input, right, is going to be your recipe, your process parameters. That's going to form the bulk of your material. And once you've got that, like Glenn said, you lock that down, and ideally you don't change it unless you absolutely have to. And then documenting everything after the fact is going to be just as important, and making sure you've controlled the process throughout, and again, documented it appropriately.
So Matt, let me ask you, if somebody's looking to get a Velo 3D system, what sort of facility requirements do they need to consider? Things such as power, air systems, argon, all the various things that kind of go with doing this.
Yeah, that's a good question. So to back up a little bit, at Velo, we started with our Sapphire Printer, which was a 315 millimeter diameter by 500 millimeter tall build volume, and using 2 1 kilowatt lasers. And then we've expanded from there. We've grown that 315 millimeter diameter to a full meter in height. And then we've taken that entire system and basically made it larger and creatively called it the XC, which stands for extra capacity. And so that's now 600 millimeter diameter platform by 550 millimeters tall, and also a version that goes to a full meter in height. Those systems utilizing 8 1 kilowatt lasers, where you're either printing individual components with individual lasers or a single monolithic component using all the lasers, whether it's 2 or 8. All those systems are currently running on Argon, and we run 50 micron layers. But to your question of facilities, yes, the machines need power. So obviously you're going to need access to power I'm going to get this wrong, 208 and 480, I'm not an electrician. The 401 and the 201 compressed air for sure. Argon are the main ones. There's also some cooling required, but that'll depend on the system you get and kind of what your existing facilities are. But no need for like clean, what's that called? Like clean room type environments. What we typically say is if your employees would be happy, then the printer would be happy in the environment. So don't want an uncontrolled environment where 100 degrees in the shop or 40, 30 degrees, but doesn't necessarily need to be, 70.25 degrees and 38% humidity.
Yeah, we've actually gone through that process. We just accepted the Sapphire, I think about a month ago, a little bit over a month ago. And, if we weren't already in the process of laying out a lot of those utilities associated with power, argon, just general, all the utilities required, larger footings and things like that. If we weren't already in the process of that, that would have probably been a little bit of a, not a surprise, but I think folks need to realize that you got to have those, utilities there to run. This is an industrial machine that needs some, TLC associated with the utility. So forethought and planning is the last thing you want to do is have that very expensive machine that you've so long waited for show up, and then you don't have any way to run it.
And by all means, Vela will 100% help you on that forethought and planning. We have a awesome customer service team that'll walk you through it. Big document that tells you all the things you need, and we're happy to reach out and help.
Yeah, and it's just kind of a shameful plug for them. It's probably been one of the most smooth transitions that we've had in terms of the machines that we've bought. And that includes, 5-axis machining centers and wire EDMs. The Velo 3D was actually, the Sapphire was really, really smooth process.
All right, so Matt, if I were an engineer, which obviously I'm not, but I wanted to talk to your team. There are a lot of engineers watching this webinar today. How would they get in contact with you? How do they reach out?
Sure. The easiest way is to just go onto our website, and there's a variety of ways to get in touch with us on there, and that'll usually route you directly into one of our commercial teams, which, depending on what your needs are, folks like myself on the technical business development side will really help partner with folks who are trying to develop applications and understand business cases and get connected with our contract manufacturers. So you'll be working directly with myself and my team. We've got sales directors if you're looking to actually bring some equipment in-house. And so very easy to kind of work your way in through our website. We've also got material data sheets for all the materials we have qualified on there with some of the basic static mechanicals that I referenced. So you can go look at all those as well. And some other interesting things like links to the podcast that Rob's wife was recently on with Renette, our CMO, and some good talks on there as well.
All right, that sounds very good. I want to remind everybody real quick about the webinar survey. So if you happen to turn that off, you can click on the little clipboard icon at the bottom of your screen and it'll bring it back up. Fill that in. We would really appreciate it. Before we sign off, I want to thank our presenters. So Glenn, Rob, Matt, each of you, thank you very much. And also thank our sponsor, Velo 3D. So in the next 24 hours, you're going to receive a personalized follow-up email. It'll have details and a link to today's presentation on demand. So if any of your colleagues and friends were not able to attend this live today, they can click in and watch it on demand. So please share that with them. That would be great. And normally I just say have a wonderful remainder of your day, but I want to say tomorrow, have a great National Aviation Day, because tomorrow's National Aviation Day. So enjoy that so much as well. Thank you very much, and cheers. Bye.
Take care. It was a pleasure.
Thank you.
Thank you.